Hello, this is Ms. Brubeck. Today you are going to be learning how to deal with growth and decay. So the learning target is I can write equations that show exponential growth or decay. And what you're going to see here is the general equation for exponential growth is this right here. Y equals C, parenthesis, 1 plus R, close the parenthesis to the second power. And exponential decay is the same. Notice how growth has a plus sign and decay has a subtraction sign. And you're going to know whether to use the growth or the decay equation really by whether or not it says increases or decreases. Most of the problems we're going to be dealing with are going to say increases or decreases. And so what do all these variables mean? Well, the y represents the final amount. So, the answer that you're looking for. C represents the initial amount. Your starting amount. R represents the rate of growth or decay in decimal form. So it's the rate. We're going to be looking, and when I say the rate, the percentage rate. The percentage rate of growth or decay in decimal form, and then T represents the time. So that one's pretty easy to remember. T represents the time. So we might have to come back to this and look at it as we do this, as we do the next few examples. So what we have here is it says in 1971 there were 294,105 women participating in high school sports. We'll assume in like the entire country. Since then, the number has increased an average of 8.5 per year, so a nice steady increase. It wants us to write an equation that represents the number of women participating in high school sports since 1971. So we're going to have our equation that we saw on the previous page, but we need to decide, is it going to be a plus sign or a minus sign between the 1 and the r? And then we know it'll be raised to the power of t. So see how here it says increases? That means it's going to be a plus sign. So we're going to need a plus sign here. And then it's going to be raised to the power of t. So we need to decide, we need to figure out like what are our numbers? So first we have C. It's the initial amount. And the initial amount of women participating in high school sports back in 1971 was 294,105. Then we need to figure out our percentage rate. The percentage rate, it's 8.5%, but we need to figure that out in decimal form, okay? Decimal form. So that means we need to take that percentage, that decimal point, and we need to move it over 2 places. We're gonna move it right here and add a 0. So really the rate we need to use is 0.085. And then the time, we don't know the time because it says 1971, but 1971 isn't a time, it's a year. So we're just going to replace all of that in here. We'll have our 294,105. 1 is going to stay the same, and then our rate is going to be 0.085, and then we do not know the t. So that's our equation. I'm going to move it down just a tiny bit. That's the equation. When it says write an equation, that's the equation it wants us to write. Now it says, according to the equation, how many women participate in high school sports in 2001? Well, we need to subtract how much time has happened between 2001 and 1971. Now, if we do that math, we're going to get 30 years. So now we can change our t to 30 years. And I'm going to bring this down with our t. And now our t is going to be 30 years. And I'm going to go ahead and add this right here. 1 plus 0.085 is just going to be 1.085. If you don't believe me, go to the Desmos calculator. 1 plus 0.085 is 1.085. So that's my function now. Now we just need to simplify it. So this is where the Desmos calculator is going to come in. You can just plug it in just like this. 294,105 times, we said 0.085 to the 30th power. See how That doesn't seem to be giving me, oh, you know what I didn't do? You have to put a parenthesis. You have to put a parenthesis around the second part, just like this does. So see how mine looks pretty much just like this. Just know that between this is a invisible multiplication sign right here. Okay, and the answer that we are going to get, oops, is, oh, I put it, you know what? I put a comma. I didn't need the comma. That's why. 3,399,339.5. So we're going to round that up. So the answer is y equals 339.5. So I'm going to round this up to 400. So 3,339,400 women were participating in high school sports in 2001. So that is our answer right here. Moving on to the next slide. Same idea for the next slide. In 1950, the use of coal by residential and commercial users was 114.6 million tons. Oh my goodness, that's a lot of coal. Many businesses now use cleaner sources of energy. As a result, the use of coal has decreased by 6.6% per year. Okay, so notice the part that says decrease. That means instead of saying 1 plus, we're going to be saying 1 minus, because decrease means we're using the decay. We're using the exponential decay. When it says decrease, we're using the exponential decay function. So I gotta put my 30 here. Oh, I don't know what 30, that was the last problem. Sorry, I meant to say I gotta put my t. And then we need to figure out what are all the integers. So C is our initial amount. That's going to be 114.6 million tons. Oh my goodness, that's a lot. The rate, the R is the rate, that's going to be 6.6%, but we have to make it into a decimal. So we're going to take that decimal and move it over one spot to the left. So that's going to equal 0.066. And then the time, we don't know. We don't know how much time. We just know that they started talking about this in 1950, but we don't have a new time. So the C is going to be 114.6. Now we can just write it like that as long as we remember that we're talking about million tons. And then 0.066, and then our T needs to come over here. That's our equation. So now it says estimate the amount of coal that will be used in 2015. So we had 1950 and now we have 2015. So we need to take 2015 minus 1950, which is going to be 65. So now our T we know is 65. So we can take our equation from before and we can replace that T with a 65. And we also can do 1 minus 0.066. And we're going to get 0.934. 0.934. Okay, so now we can put this into our calculator. Just remember we're dealing with millions right now. So we have 114.6 millions times, oops, I forgot to take away the 1. When I subtracted the 1, we get this. Oh, you know what, I just realized I got rid of my T. Sorry, fixing some stuff. 0.934, 0.934 to the 65th power, and we're going to get 1.35. Now you might be like, 1.35, that's pretty small, but what we're saying here is that it's now y equals, what we're saying is y equals 1.35 million tons. So we decreased. We went from having 114 million tons to, after 65 years, now the use of coal in residential and commercial users is now only 1.35 million tons. Still a lot of coal being used, but significantly less coal than what was being used in 1950. All right, let's go ahead and look at the very last example. Now it says a farmer buys a tractor for $15,000, or sorry, not 15,000, $50,000. If the tractor depreciates at 10% per year, find the value of the tractor in 7 years. Now, depreciate means decay, basically, or loses value. Depreciates means to lose value. So if you're talking about losing value, we're talking about decay. So if we're talking about losing value, we're talking about decay. So let's have our original equation. If we're decaying, we're going to be subtracting. So if we're talking about decay, we're going to be talking about subtracting. And so here we are going to have C equals, our original amount is $50,000. Our rate is 10%, but we know we need to change that to a decimal. So the decimal, if you don't see a decimal, it means it's at the very end. So the decimal's at the end of the 10, and we're going to bring it over 2 points. So now our new 2 points to the left. So now our new rate is 0.10, or just 0.1. And then the time, they actually told us the time this time. They told us 7 years. So now we know that it's 7 years. It tells us that right here. So let's go and fill this information in. The C is 50,000. The R is 0.10, or just 0.1. And then our T, we need to move our T over. It's going to be 7. And so that's the original equation. We can then simplify it. So we're going to have y equals 50. I'll put the comma there. In the parentheses, if you do 1 minus 0.10, you're going to get 0.9. So we have 0.9, or 0.9, however you prefer. And then it's going to be raised to the 7th power. So let's go ahead and do that in the calculator. 50,000. Yeah, when you do this, you can't put the comma. So if you put the comma, it won't give you a correct answer. So no comma. You just have to do 50,000. Make sure you have 4 zeros times 0.9, or you can say 0.9 to the 7th power is going to be 23,914.4. We'll say 0.85. So y equals, what did we say? Oh, 23,914. Oh, and it's dollars. 23,914. We say 0.85. Yeah. And so 0.85 would mean 85 cents. So depreciates means that it's a losing value. So that's the thing about when you buy something new, whether it's a tractor or a car. You know, if you buy a car, they say the second you drive that brand new car off the dealership lot, it immediately loses value. Like the minute you drive it off the lot, the car is no longer worth as much as you paid for it when you drive it off the lot, because it's now being used. So if the tractor was $50,000 when he first bought it, but it depreciates at 10% per year, after 7 years, the tractor is only going to be worth $23,914.85. So if the farmer wanted to sell back the tractor, he decided he didn't need it anymore, he would only be able to sell it for less than half. It's worth less than half of what he originally paid for it 7 years prior. All right. That's the end of our notes. Make sure you turn them in on Google Classroom. Thanks for watching.